So for example, let's find, we'll find the center of mass of a wire which is lying along the curve R of t is ti plus t squared j plus 1 minus tk for t between 0 and 1. So that's pictured here, with density delta of t is root 2t squared plus 1. So again, our first we'll find the velocity vector. So r prime of t will be I plus 2tj minus k. And so the magnitude of the velocity vector will be, that's 1 plus, so it'll be 2 plus 4 t squared. And it'll be useful to pull this out as root 2 times root 2t squared plus 1. So I sort of chose these parameters very carefully, or the density function very carefully. All right, so then we can find the mass. So the mass will be integral c delta ds. So this is integral 0 to 1. Delta is root 2t squared plus 1. But then ds, we found ds is root 2t squared plus 1 dt. This is root 2t squared plus 1 dt. So this is root 2 integral 0, 1 2t squared plus 1 dt. And I'm just going to evaluate these plug these integrals into Wolfram alpha to evaluate them, and then just sort of write down the answer here, since we know how to evaluate integrals like this by now. Okay, so the mass we find is 5 root 2 over 3. Okay, then we need to do the moments. So the moments are going to be a pretty similar calculation, but now we'll multiply. So myz will integrate x ds times delta ds. Mxz will integrate y delta ds, and mxy will integrate z delta ds. But our calculation, that delta times ds is root 2 times 2t squared plus 1 dt, is going to be valid in all of these, for all of these integrals. So myz will be root 2 integral from 0 to 1 times, so x is t, so we'll have t times 2t squared plus 1 dt. This will be root 2 integral 0 to 1 t squared 2t squared plus 1 dt. And this will be root 2 integral 0 to 1 of 1 minus t times 2t squared plus 1 dt. Okay, so now these are all integrals of polynomial functions. We know how to evaluate this, so I'm just going to plug these in to Wolfram Alpha and record the results. So for MYZ, this works out to be root 2. For MXZ, this works out to be 11 root 2 over 15. And MXY is 2 root 2 over 3. So let me record those over here. Yes, XZ, 11 root 2 over 15. MXY is 2 root 2 over 3. Okay, so now we can calculate the center of mass from these four numbers. Right, so the center of mass is X bar, Y bar, Z bar is M YZ over M, M XZ over M, M XY over M. And that's, okay, so 5 root 2, oh no. So this is root 2 over 5 root 2 over 3, 11 root 2 over 15. That, okay, yeah. This is divide, this is 15. Over 5 root 2 over 3, and then 2 root 2 over 3 over 5 root 2 over 3. So let's see, this, and then this will be over 5. So this should be 3 over 5, 11 over 25, 2 over 5. So that's the center of mass is this point here. Notice this isn't on the curve, and it doesn't have to be. This is just sort of where the mass is centered.